I got two comments saying they do not understand my circle theorem video. So this is a response to them to properly explain to them how this God forbidden topic. Okay, I think the reason is behind these two mainly, this and this. How and I think probably this. How do we identify all these? Okay, well, in my last video about circle theorem of solving all of the topicals, I shared some tricks with you, but no one has time to watch the entire hour-long video. So here is the video in compressed form. For this, what you have to look out for that the angle over here and over here. You need to see by which 2 points is this angle made from. Okay, example, this angle is made from BC, and you need to see if there are lines from B and C to the origin. Okay, if you see a setup like this, then you are Gucci. Example, there was one question where it had this case. This angle up here, this blue angle, was made by these 2 points. I will name them A, B. And I also knew that AB had a line connecting to the center of the circle O. So I knew that this was 2 times that small angle, and so I could find that small angle. This is how you can do this as well. So to recap, if this angle is being made by 2 lines and by 2 points, and these 2 points have a radius drawn to them, then you can apply this rule anywhere you like. Example is like this. There might be other examples, but that is the only example you have to be careful for. Okay, and next is this angles in the same segment are equal. This is the same. Let's look around for these cat ear shapes. Very simple. Okay, if this angle is made by the 2 points, then you need to find if these 2 points also make another angle by going to the arc or going to the sector. Okay, very simple. Opposite angles of a cyclic quadrilateral. For this, what do you have to be careful of, and how do you know this? If these 2 conditions, if like every condition fails, okay, if this fails, the blah blah blah, then you have to resort. This is like somewhat of your last resort. If you cannot find this a quadrilateral, okay, you have to look at the angle opposite to it. Okay, it may be not so obvious, but one way to do this is to look at the vertices, count in any rotation, like you go anti-clockwise A, B, C, D, or clockwise B, A, D, C, whatever. Okay, clockwise or anti-clockwise. You just have to check the other vertex of this quadrilateral. Okay, so A, B, D, C. This is a pair. B, C, D. This is a pair. C, D, A. This is a pair. Blah blah blah. You can check out the examples I have in the hour-long video. Okay, this is how you basically identify this by looking at the side opposite to it and seeing if there is a angle that is being made, and if there is a quadrilateral, you can identify then later by looking at the bigger picture and the entire diagram fully. Okay, this does not work for this. If the angle opposite to it. Like example, you have a angle over here, and opposite to it you find a angle outside the circle, then no, that would not work, obviously. Well, this is a fun question where no, blah blah blah. Skip that. Okay. For alternate segment theorem, how on earth do you do this? Okay. In my last in the video, I just hand waved everything. Okay. For this, I am back again. Okay. For this, how do you identify alternate segment theorem? Okay. Well, you know, this tangent will make a angle like so. For this, what do you have to do? The angle, this angle, you have to look at the side that this angle is made by. Okay, like example, this angle is made by this side, and the angle opposite to this side will be the corresponding angle to this. See, this angle is being made by this side, so the angle opposite to this side will be will have the angle corresponding to it. Similarly, if we make an angle like so and look at this side, opposite to it is the corresponding angle. Would you look at that? And I can prove this by making this angle going up here and rotating like so. Boom. See, it works. Okay, so this trick you can do instead of looking around which angle. Oh no, you just need to look at the angle opposite to the side that this angle is made by. Okay, so that's how you can identify angle segment theorem. Okay, if there's any other third explanation I could find, second explanation I could find, so I can give you in a short, but this is one way to do it. So angle, the side that makes it, and then the angle opposite to it. That's how you do alternate segment theorem. The rest I have covered in proper detail. Okay, if you do not understand them, then I do not know how simplified you need it to be. I will go over them just one last time in this video. Okay, so for here, equal chords are equidistant from the center if OU is equal to OV, then AB is equal to CD. This means, okay, what does this mean? If we have these two line segments OU and OV, and we are sure that these are equal, then we know that the chords AB must be equal as well. Why? Because let's say that this segment is literally copied over by just drawing like a symmetry line. Okay, if you draw like a line of symmetry through here, then you will see that indeed this is true. Okay, if you were to rotate this, and flip it, then you will see it also makes sense. If AB was like crossing, if this line was crossing, then this other line would be also crossing like so, and you can see that this rule still applies. Okay, because this OU cuts the line AB in the same exact spot the line OV cuts CD. Okay, so you can use this rule to your advantage. Okay, in questions. This has never been, it might have, but like in a very old past paper probably. Okay, I have never seen this question. If there are examples, even in igcse or Excel, then please let me know. I have only seen the O levels 42 and 4 papers, okay, in my 20 years of living. Okay, for this this is just simple. If you have any chord in the circle, any chord, literally any single chord you want, okay, any chord, trust me, any chord, and you draw a radius. A radius is, everywhere. You can have a radius over here, you can have a radius over here. If in a radius will cut this into two parts equally, okay, instead of thinking the bisector of this, you can think of the radius being drawn to cut it, okay, like the opposite case, the radius being drawn to cut this, it will cut it into two equal halves always, okay. So you can trust me on this one, it will cut it into two equal parts. Example, this I made a bisector immediately because of this being a radius, and boom, this is in two equal parts. I can draw and show it to you. This blue section will be same. Please wait a moment. It will be the same as this section, okay, minus the rotation bit, but it is indeed same. If we draw a radius to it, it will be 90 and cut it into two halves, okay. So this rule applies everywhere, okay, and this is mainly used for using Pythagoras, okay. So that's only where you will use this. For here, it is obviously simple, dead simple. You can think of this as it using this rule, the 90 tangent rule, and it making a 90-degree angle over here. And this kite shape, instead of thinking of it as a kite shape, it is two triangles where this angle would be used to complete this angle, or this angle be used to complete this angle. And since these two triangles are congruent, we have these two angles add up to this entire red angle, and opposite to it, these two blue angles will add up to this big blue angle. And so this is how this OT is equal to 180 is shown, okay. This is a very useful point, and I have used it in my 1 hour topical video, okay. Next, these are very simple, okay. For this one, I did have a question where it did not tell me that it was 90, but I assumed it was 90 and it was correct, okay. To know this, you just need to find out that this is a radius by yourself. Question will give it to you, it is a radius, or you just have to feel it, okay. Sometimes that's the worst case, okay. And I hope it's not a just feel it case, okay. I have the interactable graph down below if you guys want, and bye.